Alright, so we've been talking about functions, and one of the most common types of functions that you run into in algebra is what's called a linear function. And a linear function, when you graph it, and we'll be talking more shortly about how to graph them, a linear function, when you graph it, it's called linear because it produces a straight line. And you'll, like I said, in a couple videos, we'll see how to do that. The definition of a linear function, what makes it linear rather than some other type of function, is that the only math operations that are happening are adding, subtracting, multiplying, or dividing. There's only a single variable in it that you're doing those things to, and it's being added or subtracted to other numbers rather than variables. So I'll give an example of some things that are not linear functions. This would not be a linear function because you're not only adding, subtracting, multiplying, dividing. In this case, you're squaring. So this is actually not. It will produce something called a parabola. Here's another example. This is not a linear function, square root of x. That's a square root sign because, again, you're not adding, subtracting, multiplying, or dividing. Here's another example of something that's not a linear function. Okay, x times z, because this is not a single variable. You have multiple variables here, so that's not going to be a regular graph. Here's another thing that's not a linear function. Okay, if you have x on the bottom of a fraction, that's not only added, that is dividing, but it's not dividing x by a number, it's dividing a number by x, so that's not going to produce a straight line. Okay, all of these would be examples of linear functions. Y equals 3x, or y equals x plus 3. Okay, that's adding, or y equals x over 3, or y equals x minus 3. You can see we're only doing these for math operations. We only have a single variable x, and we only have constants or numbers. In this case, we're using 3. So there are 3 different ways to write linear equations or linear functions, and I'm going to show you the first one right now. It's called standard form. Okay, so this is how to write an equation in standard form. So we want to be able to do that, and here is what standard form looks like. You have a number times x plus a number times y equals some third number. A, b, and c all stand for numbers. And the rules are these. A, b, and c have to be integers. That means whole numbers. So for example, 3 is an integer. 3 and 1/3 is not an integer. 3.2 is not an integer. An integer is just a number that doesn't have any fractions or decimals. Or it could be a negative number. So these don't count as integers. Okay, the other condition for standard form is that a cannot be a negative number. So for example, if I wrote an equation like this, negative 2x plus 3y equals 5, that's not in standard form because this a number, remember a is the number attached to x, it's not positive, it's negative. So the way that you could fix that is multiply everything by -1. And then finally, a, b, and c can have some common factor. So here's what that means. Suppose we had 10x plus 20y is equal to 30. This is not in standard form because those all have a common factor of 10. So if you divided this whole thing by 10, you would have 1x plus 2y equals 3. Now that's in standard form because they have no other common factor besides the number 1. So let's try and see if you can pause the video and try this. Based on those 3 conditions, let's see if we can write the following equations in standard form. We'll just go down the list of conditions. So first condition, a, b, and c have to be integers, and that's correct so far. -12, -3, -12, those are all integers, so that works. Second condition, a cannot be negative. Okay, well that's not true right now because this is the a. A is the number in front of. Let me rewrite this so you can see it in standard form. Okay, equals -12. We just swap those. Remember, here is standard form. This is what we're trying to get it to look like. So a can't be negative. How can I fix that? I can multiply everything times -1. So you have to do it to both sides. Whatever we do to one side has to be done to the other. So -1 times -3x is 3x. -1 times -12 is 12y. -1 times the other -12 is 12. So at least now we've passed this condition. A can't be negative. Final condition, a, b, and c do not have any common factors. Well, if you look at these numbers, they do have a common factor, and that would be 3. 3 goes into all of these numbers. So let's divide everything by 3. So 3x divided by 3 is x, 12y divided by 3 is 4y, and 12 divided by 3 is 4. And now this is in standard form. Now here a is equal to 1 because there's a 1x right there. B is equal to 4 because this number is 4. And c is also equal to 4. So now it's in standard form. Alright, let's try the second one. So the second one we also want to put in standard form. A, b, and c are integers. That's our first condition. and that's already failing because this right here is not an integer. So what can we do to make it an integer? We can multiply everything by this number, by 3, and you'll see why. So let me rewrite this for a sec. So we're going to do 3 times this thing right here, and let's see what happens. So 3 times 4, that would be 12. 3 times x would be 3x minus, and then 3 times 5/3, this 3 on top and this 3 on the bottom will cancel, and we're just left with minus 5y. Okay, so that checks off that condition. Now they're all integers. A can't be negative. Well, it's not negative. A is 3, and 3 is not negative. And A, B, and C don't have any other common factors. Well, if this were a 6, then they would have a common factor of 3. 12, 3, and 6 would have common factor of 3, but it's not. It's a 5, so B is negative 5. And C is equal to 12, and that's as much as we can simplify. That's already considered in standard form.